Alright guys, hello. Uh, Here once more continuation from first part of the video. Okay, probably you have tried it and you will see a little bit of errors or messages giving you mistakes or errors that are syntax errors. Okay, just want to conclude with the program, right, with some corrections and things that can be modified in the program from the previous video. Okay, I did mention that we need to have an individual counter. Okay, I declared it as T. All right, this T or this independent counter is not actually counting any items in the program, but rather just guiding, all right, the number of repetitions of how many temperature was stored in those particular days. We don't know how many days, but that T will be in charge of recording how many the temperatures were recorded in um, in whatever amount of days. Okay, but I will initialize that with a 1. Okay, and you can see it here that it will say that it starts at 1. Okay, um, as a normal counter or the first loop, it comes here, it starts at the first one plus the initial t, I give it as 1, makes it 2. All right, whereby here it will kick in as the second loop, right, where it connects the second loop. Then it goes here, say asking for that second loop. It records third, fourth, and so on. The same way in the cumulative totaling, where temperature, if you enter 3 for the first day, it comes here 3 plus what is tot. Tot is declared as 0. 3 plus 0 is 3. Second day is 2. Then temperature is 2. The previous total is 3. So 3 plus 2 gives me 5, and so on. All right. Good. Additional to this, I added a t colon equals t minus 1. Why is that so? All right. Simply because whenever I record the last temperature and I terminate it as 999, okay, the temperature itself will not be recorded. It will not be accumulated. Nonetheless, the loop is being counted, okay, and it will divide by the amount of the loops, and I will show you right away. Okay, of course, also I added here saying an information. If you want to conclude the program, people may not know how to use your program. All right, they press enter to exit, and of course also a little information saying, all right, the program designed to register temperature. Okay, um, also here I could have added more information if the user doesn't know, all right, to close program, enter the value 999. Okay, probably information that the user doesn't know. Okay, let's look at the program now. Right. It's running. It probably takes a little while. I forgot to disable my antivirus. This antivirus will terminate it because it needs to actually analyze it. It may take it as a virus. Okay, but it will reinitialize. There we go. All right, says that this looks safe. Okay, let's look at it. Information is here. Okay, you can see there. Good day, program designed to register temperature. To close program, enter the value 999. Enter the temperature of the day. Let's see 3. Day 2, you can see the continuation of 2. I put 2. Day 3, I would put 5 inches. 4, let's say 6 inches of, 6 degrees Fahrenheit, let's say, temperature. And let's say no more days. Okay, just remember that this could have continued. I want to terminate it. To disobey the rule and make it terminate, I must enter the opposite of what I put. Once it is not equals, well, once it is equals, it will terminate. 999, and look what happens. When I press enter, the average temperature is 4.0, right? Degrees Celsius, degrees Fahrenheit, that can be modified. Look at it, 3 plus 2 plus 5 plus 6, right? This gives me 16. Divide by 4, it gives me 4. The lowest is 2, the highest is 6, right? Now, why did I use this t colon equals t minus 1? Because if I don't remove one of the counters after the end semicolon, after this is finished, all right, this fifth day will be counted as the loop, right? Remember, divide by t, and t knows that it stops at 5. So it would have divided 5 into 16, and the answer would be something else. So therefore, I just take away that one extra one. Nonetheless, the temperature here, 999, is not part of the 65213, right? So I will exit the program. Okay. And I can quickly show you, right? If I leave it with that, without that T, look at what happens. Okay, I will need to wait again, couple seconds here. And I'm working with time with these videos here. It will be, there go, okay, and okay, look at it. If I enter the temperature being 3 degrees Celsius, 2 degrees Celsius, 5 and 6, and looking at the fifth one, I want to terminate it, I put enter 999, the same values I'm using, which at totals at 11, sorry, at 16. 6 plus 5, 11, plus 2, 13, plus 3, 16, divide by 4, it should be 4. Okay, but if I press enter, it gives me 3.2, which is actually counting the fifth loop. Okay, and it's dividing 16 divided by 5, which is giving me 3.2, and that is wrong. Okay, the lowest is giving me correct and the highest is okay. So that's why you need now to do the T, remove that loop, but that goes after the end semicolon because that finishes the loop. All right, it brings the last T, all right, here before it divides, and then you take away one, all right, and it gives you back that less one loop. All right, good. Now the same program, guys, in the lesson 30 was for you to create the flowchart of it. Let me go here. You can use the same Microsoft Word, insert, shapes. You have a section here for flowcharts. You know the different diagrams and its purposes. There are special programs also that you can use for flowcharts. And I'm using here this called Smooth Draw. I'm using this not only for teaching purposes, all right? But quickly, let me show you the flowchart that you should have uploaded this week that passed. You already know that oval means start of a flowchart. Very important, the arrow. Okay, arrow is very important. That indicates the flow of data. If we recall back what the information is and we recall our program, all right, you ask the user to enter, okay, and to do input and output, we use what is called the parallelogram. Okay, in there you have information. Normally reflects back your algorithm. Okay, it reflects back your algorithm. Temp, because that is the name of the variable I'm using. I have here continues, right? In here I will be using, all right, rectangle, the assignments. In other words, to what I'm assigning low, which was to a dummy value or a value that probably would never be recorded in a temperature, high, so I would be able to compare it, all right? Once it is higher than 0, and automatically it tends to be the highest temperature. When it's lower than a temperature that doesn't exist, it will be the lowest. All right, then we had the total, and you will excuse me, all right, with not writing it clearly, but just follow up. All right, total initialize with 0, all right, and uh, because of space, all right, just let me see. Okay. The space, let me see, hard eraser here. Okay, now let's go back to my pencil. Right here I go. I could have used the other one that says T. I initialize with 1. Okay. If you wish, you can do it individually. Then I have here follow up the loop. While loop is also represented in a diamond, and contrary to what we have in the algorithm or in the program, all right, contrary to saying while temperature is not equal to 999, do in the flow chart, okay, you do the opposite, saying that is equals to 999. That's the terminating value, okay, 999. Once it is equals, then it should terminate, okay, it should terminate. But once it is not equals, then do the following. What will I do? I will take that temperature that was entered at the beginning and compare it. Okay, if that temperature is greater than high, okay, if that is true, then that means that high will be assigned by that temperature that was recorded to be the highest. Okay, now also that if that is true, yes. If not, all right, that same temperature goes to another another decision. Okay, goes here if temperature is less than, okay, sorry again, less than to high, which is 999. If it is less than high, then if that is true, then automatically you're assigning that high, sorry, what did I do? If temperature is less than low, this should be low, all right? Low, my bad. Thank you for having patience, all right? If temperature is less than, all right, less than low is 9999, automatically the lowest, and that means that low is that temperature taken. Okay, now those two connects. That is the loop that happens for each one that is being recorded, and of course for each one also you must be aware, okay, that at the same time we are accumulating our totals. Total equals plus your temp, okay, and at the same time, arrow very important, it is also, okay, counting here t equals t plus 1, and the loop is continuing, right? That loop is happening over and over and over and over until the person enters 999, then this goes here, all right? Remember, it takes back the one loop, which is t equals t minus 1, goes there, another processing, which is average, ouch, my mouse guys, my mouse, equals total divided by t, all right? And then after that, then of course, you have the results. You can do it in one big parallelogram, print, lowest is lowest, average is average, highest is the highest, okay? The same thing as the word says print. And then from there, you conclude with an oval